Hello friends, it's me again. In this video, I'm going to start walking through how I'm going to put together a essentially setup to program the robotic arm to repeat a task over and over. I don't want to sit here like I did in the lecture video and write down all of the different positions of the servos and do the math horribly in my head and have them not match up perfectly. Right? Like I want to control the arm and move the joystick so that it gets to a certain spot and then capture that position and have it stored so that I can come back and use an array to then cycle through a bunch of commands. So what do I want? Let's think about what the pick and place program will be, right? Like I want the robotic arm to come over, grab a block, move back, move over, and place it in the final spot, and then let go. And then move back to the original spot, hopefully, or back over here, and pick up the block again, and then move back and place it, and go back and forth over and over. So I need a bunch of different locations, right? I can actually, if we go back to my LERP testing program, I had a start and an end. And that was the simple case, moving from one spot to the next. The problem is I'd likely need on the order of 5 to 6 different specific locations to move the arm to so that it can perform this task, like move over to pick up the block, hopefully not knock it off the platform, close the gripper, pick it up, move it over, place it, let go, and then do the entire thing over again when it's coming back, not just completely blast the block off the platform. So we'll need a bunch of different positions and likely the speed at which we want that to move. One of the challenges I normally do in the lab, which I totally should have built into the simulator, is trying to throw blocks and land them in a box. Maybe I'll add that in later in the quarter because that's pretty fun. But like literally going through the task of picking and placing is one thing, but when you're trying to like slowly pick up a block and then move back and then rapidly go forward and let go of the block, you have to move at different speed every single time. And the same is true for the pick and place. If we don't want that block to fly out of the gripper, we should set a specific time for it to move from one point to the next. So I need multiple locations, like snapshots of movement throughout, and a speed at which I want to perform that task or that movement. So if we go back, we're for the pick and place, the final one, or let's say we've got 6 positions, 6 points in arm path. And we want to move from one point to the next. And this set of, like I said, 6 is going to get us moving over, picking up the block over to the final spot and letting go, and then repeating over and over. So what do we want to do? Well, we can have a loop, and let's see then, we'll say loop, because we can determine what kind of loop later, over the entire task, which is placing a block. Loop for total block placement, and we'll say for each block, because this is the larger task of picking up and moving it. That's what this loop is for. And inside that loop, we needed to move from one position to the next. And so the first thing we need to do is move from the current position, which I guess we don't even have, or I guess we could say just immediately move to a starting position. Move to start. Right? That'll be the first point And we can think about that. We probably want it set back from the block. We don't want it to knock the block off whenever it returns to this default start position. So we'll move to the start, and then for each point or data point, we'll call it not points, positions. For each position, lerp to position over given time. So we're going to have some amount of time for each movement where we want to say, let's say to the start position, we'll just snap to it. For picking up or for moving over to the block, we'll say that movement needs to take 2 seconds. For closing the gripper, that's 1 second. For picking it up and moving to this, like maybe moving slightly at an angle, that's 3 seconds. Moving over 3 or 4 seconds. Placing it down a couple seconds and then letting go 1 second. So each one of these movements needs to have an associated time with it. And so we need different positions and a time that we want it to take to get to that position. So what can we build in the short term to do that? Well, we can say that we want to write a program to collect those positions. So what could we do to actually collect them? Or right now we've got a way in the one from last week, we've got one that just follows the positioning, right? And if I were to run this right now, I can position it anywhere I want. Now it'd be nice to have some way to input into this, like I'm at a spot, I want to now capture this position or print it out to the display or the command window. I think the best way to do this, or at least bringing back in the physical side, is let's wire up a button so that we can press a button on the Arduino and it'll print out what the current servo positions are. So give me a second and let me set up the other camera and we can start doing that. I can hit the pause button. All right, so what I'm going to do is just hook up a push button on the Arduino, and then we can use the logic from there to signal like you should print out the current servo positions right now. So I've got the button in there. I'm just going to pull in ground. Go here. So ground and then 5 volts. So ground to the black and 5 volts to the red. And then to the button, I'm just going to do a pull down resistor. I picked one of the 330 ohm resistors. That should work fine. Going from the bottom pin to ground. And then on the other pin, the pin on the top for the switch, I'm going to use a wire to connect it to 5 volts. And then from the side that has the resistor pulled to ground, I'm going to put a wire and take it over to, let's say, D4. All right, so just a push button switch, and we can test it. I can come back over here and say A is equal to Arduino and not pass it anything. One second. I think it's plugged into the wrong computer. All right, so in theory it's plugged in. Oh, it says detected. All right, let's try that again. So we can connect to the Arduino. Should have done this and then hit unpause. I'm not editing out these weights because I want to show you it's just as painful for me. Doubly painful for you now because you have to wait for it on your own computer and mine. Big plans for the weekend? Sounds fun. Oh yeah. Mm-hmm. Come on, MATLAB. All right. So we can now read from D4. A dot read digital pin, pass it D4. We're just making sure that the button works. Hey, it works. Okay. And there's a major delay in my video. That's strange. So what we're going to do is come back and figure out how we can modify this code to capture the current positions. Right now we've got it so that, think about this. We've got it so that it, in the while loop, it reads voltages, or reads potentiometers, reads pots, and then really we want to be able to access the servo positions that are being written. So we can say map voltages. So we'll map, I might as well finish writing, map voltages to servos, servo positions. And then, sorry, I can hear my kids stomping up the stairs. And then we're going to write the servo position, and I'm going to pause for a second. All right, so we're going to map the voltages, and then at that point, we can write them again. Write positions to servos. And then we'd like some way to be able to signal, like, I want that information now. And so now we can use the push button to say, if the button is pressed, like, that's our signal. We're going to print out the data, and that way we can more easily capture it. So let's say if the U button is pressed, print out positions. Right? That doesn't seem too bad. So what we need to do is, going back to our program first, we've got the read potentiometers, we've got a way to map them, but we're not saving that as a variable. So we need to change, right after we read voltages, we want to, and this, might as well throw in these comments, read voltages, and then we're going to map voltages to positions. And so in here, we'll say, we'll use that SP variable. We'll say SP1 is equal to, and then we can grab this side of there. SP2 is equal to the next one. And this is going to simplify how we write to the servos. We'll see that in a second. We'll grab this third one and say SP3 is equal to this. And we could do them as an array, and in like an array declaration. I'm doing it line one at a time just so it's more clear what the mappings are. Let's get rid of these, and then we can say we'll use that. And that would be SP4 And then this last one would be SP5. So now we've got 5 servo positions that we want to use for the servos. And for this, we can go do another I equals 1 to 5 loop and write those to the servos. For I is equal to 1 to 5. And then we want to write those servo positions. So we'll say index I, and then SP of I is the position that we'll write to it. And then we can end. And in theory, we haven't changed anything, right? But we're storing the positions as in a vector form. And so we'll be able to access them later on. So let's try this. We should get the exact same behavior that we did before. Servos not working. Oh, it is. Why is the elbow not working? Oh, I did them out of order. I was not paying attention. So 1 matches up. This is 5. Let's rearrange them so they're in order. This one is 3. This one is 2. And this one is 4. So let's go like that. And now, in theory, it will work like it's supposed to. Okay, it's corrected now. Elbow is correct. Waist is correct. Shoulder correct. Gripper works. And wrist. All right, so now we've got the same code that we did earlier, but we're storing the servo positions. You guys couldn't see that because my camera overlay is not right. Let's try that again. There we go. You don't need to see the button. So now you can see I've got the motion all matched up now. So we've got all 5 of those positions. And if we go back to what I said down here, now all we need is when that button is pressed, we're going to print out the positions. So if we go back into that code and do Control C, up above, we can uncomment out the Arduino object. We actually want to make a connection to it now. And then down here, I can say if Arduino object.read digital pin and put in that D4, then we want to go into that. And I've set the button up in a way where if it's not being pressed, it'll be pulled down to ground or a reading of 0. If it is pressed, it will be pulled up to 5, and we'll get a reading of 1. If you are seeing that and it's still confusing to you, don't feel bad about saying read digital pin is if it's equal to 1. That means you know it's being pressed. If that's more clear to you, don't feel bad about doing it. Whatever makes the code more readable for you means it's better in terms of your long-term being able to come back to it and possibly use it again. So we'll read digital pin is equal, if it's equal to 1, then we'll go in here. So let's then say, let's just print out, let's display SP. It'll take a second to load the board. I will tell you when it's pressed because I can't show both at the same time. But I'll press the button. It's printing it out multiple times because I didn't put any clause about it not being pressed previously. So let's change that so that it only prints it once. Let's say out here we can say button was pressed is equal to 0 or false. And then in here, we want to say if the button is currently pressed and not previously pressed, or the button was not pressed previously, then print it out. And let's even say button is pressed is equal to this. And so now we have two variables, right? Button is pressed. So if the button is pressed and wasn't pressed previously, then display it. And then after this, we can say button was pressed is equal to button is pressed. So the next time around, it's saved that state of the button. And the next time through, it will say, well, it was just pressed and it's currently pressed. So I don't go into that if statement. So let's give that a try. So press it once, press it once, hold it. It's only printing once when I press it, no matter what, even if I hold it. Okay, so we've got that. We could probably clean this up a little bit even. We could say, stop that code. Let's print it out so it's nice and easy for us to read. So positions equal to, and then print out SP. Let's try that. What happens if we add an array on there? I don't like that. That's not going to help us cut and paste if we wanted to take that route. So let's just print out, better yet, let's print on a different row. So positions equals, and then the next row down will print it. So let's try that again. Gotta wait for it to update. So now we've got those positions, and if we really wanted to, we could even say like, which position is this going to be? Let's put another index out here. Let's say j is equal to 1. And then within here, we could say position j is equal to, and then it'll print on the next line. And then after this, we can add to the index j. And so each time we go through here, we should see position 1 is equal to, and then the set of 5 numbers. Position 2 is equal to, and a set of 5 numbers. Unless I'm full of it and made another typo. So let's press it once, position 1, 2, 3, 4, 5. Good to go. So now we've got it printing out, and we could easily say, okay, those are the 5 positions I'm going to do. Now I'm going to go over to, say, this pick and place programming and create an array. This is my first one, put a semicolon at the end. Maybe I move it a little bit, and then I push the button, and then I copy those, and then come back over and paste them there. That's one way to do it, and let's start out that way, and then see where we get to. So let's Control C. Going back, so now we can capture each one of those. I just have to successfully pick up a block and place it one time and record each one of the steps as I go. Let's just do that slowly, probably. Feel free to speed up the video. So I'm going to, that's approximately right. Bend the shoulder, elbow a little bit. Oh, already messed it up. Oh no, get out of there, box. Oh boy, I did it. Oh, there we go. Should have put a reset button on here. I'm just trying to knock it off to get it in the right spot. All right. Oh, that's what happened. It goes through the wall. Let me restart the program. All right. So I positioned it, hopefully got it lined up. Now I'm gonna move this button over, and I'm gonna push the button for the first time, and that's gonna be my start position. And then I will move the shoulder down. And this will be the second position. And then I'll close the gripper. Third position. Move up a little bit. That's my fourth position. I'll move over. And straighten it out. Oh, wrong one. We'll say that's another position. And then one more, and then release the gripper. And that's the last one. All right, so we've got 7 positions. One of them we're going to label as the start position. So let's stop that code. And come back and say for position 1, one second. All right, so we've got that start position. Copy it again. It's equal to, and throw it into an array. And then we need all the other positions that we're going to essentially move to over a given time. So we can do that. It's the first one. Semicolon at the end to do the next row. Some of these, there aren't huge changes from one servo to, or from like on a single servo, but might still be important movement. The gripper stays the same most of the time, but that makes sense, right? And then this final one. So now we've got the start position and then all of the intermediate positions. And we want to, just like I said, where's that? That's the capture, right? But I guessed at 6. I wasn't too far off. We're gonna loop to do this for each block that we want to pick up in place. And so let's say we want to do a pick and place operation for 10 blocks. So let's say for I is equal to 1 to 10, throw an n down there. And then we want to move the arm to the start position. So going back, we need to set up the servos in the first place. So let's go back to that lab 3 task and say, I'm going to do the cheating way, and copy this. Totally don't need the Arduino, but we'll drag it along and then delete it. So we clear everything, create a connection to the MechaGAD software. We've got our potentiometer pins. We've got our servo pins. Technically don't even need the potentiometer pins. We've got servo pins. We set up all of the servos and comment this out so we don't see it. We've got the start position and all of the other positions. And then for 10 times, we want to first move to the start. And that entails saying for I, we're already using I. Let's say for block count 1 to 10. And then in here for I is equal to 1 to 5. And we'll write each servo, so ms of I dot write position, and then pass it the different positions. For this one, we're doing the start position one, so we can specify start position index I. Throw some space down here. So we'll move to the start, and then the next one is for each set of position, the start and the stop, which is we have to start. I'm going to put the start. Does this make sense? Questionably so. I want to move to the start initially. Do I even need the start? I totally don't. And in fact, it'd be easier if I didn't. So let's get rid of that. Let's throw that in as the first row and get rid of start position. And we can say, in this case, positions, we want the first row, comma, sub I. And then should be right? Let's test that. Yeah. For some reason, I thought it would be aligning them vertically. So we've got the first position in there. Now we want to move to the second position from the first. And so we'll say for each, I'm going to put this in as a comment, for each additional position pair, lerp from one to the next, right? And so we'll say in here for P is equal to, how many positions do we have? We want to start at 2 to the length. What do we get for length of positions? Five. What do we get if we say length positions comma 2? Too many input arguments. Really, we want the size. Or alternatively, we could get the correct count by saying, what if I grab the first column out of there and say, what's the length of this? We could say all of it, comma 1 will give us how many positions we have. I had copied and pasted 2 there, so now we can say to the length of positions, colon, comma 1. And we want to lerp from the previous position or the current position to the next position. And we need a time to do that over. So let's say time to lerp is equal to 3 seconds. And in here then we could say while first start a timer tick, and then while the timer talk is less than time to lerp, we will create a new servo position array. So lerp position is equal to, and then we can use the function lerp and pass it we want the start position, which will be positions, and we want the previous position. So P minus 1, comma, colon will give us the row. And then the end position is positions P comma colon. And then the time will be talk divided by time to lerp. So we've got our lerp position. Getting there. Let's see if we can. Throw that onto the next line. Nope, doesn't let us do that. Let's just get rid of some of the space. Okay, fits. And then for each one of those, we want to write those to the servo, to the appropriate servo. So then we can essentially copy and paste this down here, indent it appropriately, get rid of positions and say lerp position. We don't need the first row because it's only a single row. And so we're passing it index I, which is associated with the servo or the servo as well. Think it's gonna work? Maybe. Let's give it a try. Goes really fast back to that. We sit here for hours. It'll be like a Nyan Cat video, except it'll just be Dr. Patterson watching his own robotic arm simulator, moving blocks back and forth. All right. What are we at in terms of time? 37 minutes. I was gonna add in something where you could enter in the time and it would save it. Let's do something better than this. Let's stop and let's say, oh God, I would need to record all of them again. Let's call it. That's good. I'll also be sending out the first project info. So hopefully you can enjoy playing with the robotic arm and the lerping functionality before you get into the first project for the quarter. See you later.